In this video, we're going to look at determining supply and demand equilibrium. So first, before we get into the math of it, it's important to understand the scenario. So in economics, you have a supply side and you have a demand side. And the theory is as demand goes up, supply will go down, because that means more people's buying the stuff. It's being demanded more. And as demand goes down, supply will go up because fewer people are demanding or buying the stuff, and therefore the supply is stockpiling. So the hope in economics is that the supply and demand would equal out and the system would be balanced. And this, we call this equilibrium, and you can have equilibrium of supply, equilibrium of cost. And so that's what we're looking at, is we're looking for a place where we can balance out the supply and demand, or kind of like economics flow, so to speak. Now, when we're looking to find the equilibrium point, the hard part is coming up with an equation that would govern the supply side and that would govern the demand side. For the problems we're going to be looking at, the equation will be provided for you. So that makes it a lot easier. We're just going to use the idea of solving a system of equations to determine where the balance out point is. So let's look at a scenario. Alright, so the following demand and supply models describes the prices for unleaded premium gasoline, where P is the price of a gallon of gasoline. Okay, and so we have a demand model and a supply model. Again, the hard part in real life is coming up with those equations that model each side of the economy, but here they're given to us, and so we're asked to find the equilibrium quantity and the equilibrium price for a gallon of unleaded premium gasoline. Now here's the deal. The quantity is the number of gallons of gas that would be at that equilibrium point, and the price is the price for the gas. Well, the quantity in these equations is given by X, and the price is given by P. And so we have a system of two equations with two variables. We're essentially finding the point at which these two equations intersect, or the XY, or in this case XP ordered pair, where these two equations coincide. So we'll solve the system, and that'll be our equilibrium point. Now, with this particular system, we have three ways for solving systems of equations. Graphing is kind of off the table because of all the crazy decimals. And then we also have the addition method, and we have substitution method. Either of those methods would be fine. I like the idea of using substitution because these are both solved for P. What that means is I can take what P equals in one equation and set it equal to the P in the other equation. Or in other words, it just breaks down to setting the right sides of each of these equations equal to each other. Alright, and so there's the equation with the right sides equal to each other. This gives us an equation that only has an x variable. So now we can solve the equation for x. Alright, I'm going to start solving this equation now by subtracting the 0.002x from both sides of the equation. Doing that gives me a negative 0.006x plus 8.7 equal to 1.5. Now I'll work on getting x by itself by subtracting 8.7 from both sides. Alright, that gives me a negative 0.006x equal to negative 7.2. And then I'll finish up getting x by itself by dividing both sides by the coefficient of x, the negative 0.006. When I do that, I'm going to get 1200. So x equals 1200. Going back to our scenario, what that X stands for are gallons of gasoline per day. So the place where demand and supply balance out is at 1,200 gallons of gasoline a day. That's when everything that's supplied equals everything that's demanded. Now what we do, again, it's a system of equations. So we have one of the variables, and with that we can take it and substitute it back into either of the original equations to find the other variable. I'm going to substitute it into the demand side model just because it's first. You could do either one, you'll get the same result. So again, I'm going to substitute the x equal to 1200 into the demand model. When I do that, I get that the P equals negative 0.004 times 1200 plus 8.7. So when I pound that out on my handy dandy calculator, I get 3.9. Since we're dealing with money, because this is the price side, it's going to be $3.90 or $3.90 per gallon of gasoline. So what we found is that the equilibrium quantity is 1,200 gallons per day, and the equilibrium price is $3.90 per gallon. Hope you find this helpful. Let me know what other questions I can help you out with.